So it's my pleasure to introduce Dr. James Timber, who is a postdoctoral researcher at Ryerson University and who does research on trees in the city. James has a bachelor's degree and a master's degree from Dalhousie University, and he completed his PhD from Ryerson very recently. And it's a pleasure to have him with us today to speak about complex social-ecological systems, which is how we turn to understand the trees in the sea. So without further ado, I'm going to invite James to the stage.
Thanks, Camilo. Yes, it was very recent since I completed my PhD, and I think you're the second one to ever call me Dr. James, other than my mom, so I appreciate that. So today, I'm going to talk about the urban forest. Camilo and I, by I'm sure no coincidence, as well as Lauren, have a mutual colleague, Peter Dunker, who Lauren mentioned. He supervised my master's work and some additional research at Dalhousie, and he supervised Camilo's PhD. And he got us all excited about urban forests. My initial background is in commercially managed forests and climate change, but I wanted to focus on the urban forest for my PhD because I thought it would be a lot cooler because it's a lot more complicated. One of those things is true, and actually, you know what? Both are true. It's complicated and it is really cool, but it's a difficult system to conduct research in, and it's a difficult system to manage because it's what I would call a social-ecological system. So I'll give a bit of context to that term as well as the urban forest before digging in here. Are you familiar with the term urban forest? Have you heard that thrown around before? Yeah? Just you know, I always give a little bit of preamble that I think when Camilo and I are talking about the urban forest, it's, you know, patches of forests within urban areas, like your Central Parks or your Stanley Parks, but it's also, from what I see, all the trees in the city, the entire city itself, whether it be a downtown corridor with some managed street trees that are maybe struggling, a university campus with some lovely cherry trees over there that are enjoying the warm recent weather, I'm sure, or anywhere in between. So that's what I'm talking about when I mean the urban forest. And I'm going to talk about how do we manage this complicated resource and this complicated ecosystem, because it is this really different set of habitats and a different set of structures that comprise it. And I'm going to talk about the research that I did for my PhD to try and help to answer those questions about how we can manage this complicated system. So I think, as you probably know by now, cities are really important, especially in Canada and North America, where over 80% of Canadians live in cities. So we're really an urban country, despite our vast geography and resource base and the importance of, you know, more traditional natural resources like, you know, we talked about environmental assessment and that I've looked at before in forest management. But really the most people that are living in cities are exposed to nature in the city. You know, especially a lot of people who might not have opportunities to get out of the city. The urban forest is not just important to them, you know, from an ecosystem service point of view or a benefit point of view, but that's their daily dose of nature. So it's a really important system. It's really valuable, and it has a lot of what we call ecosystem services. So some of the functions that an urban forest does, just by being an urban forest, have a lot of anthropogenic benefits for us. These are what we call ecosystem services, and they range from in the summertime, trees capture a lot of rainwater. So in big storm events, which are becoming more frequent, they slow that rainfall and they slow the stormwater down so that it doesn't all rush into our stormwater infrastructure at once, cause flooding or damage. So that's a thing that, you know, municipalities and even engineers place dollar signs on, and they see that as a tremendous value. Green infrastructure, it's often called. They also remove pollutants from the air. These are a lot of the more quantifiable ecosystem services that have a lot of prominence in research on the urban forest because they can be quantified. So take that with a grain of salt. They are very important, but there are equally unquantifiable important values as well, which will be the focus of Camilo's talk, I'm sure. So that being said, the urban forest is important. It's important that as citizens in a city, as important as neighborhoods, community organizations, or what have you, and especially so as municipal governments who have largely been assigned the task of this resource. It's important that we manage it so that we can maximize these benefits and minimize any potential risks or threats or costs associated with the urban forest. But as I was alluding to at the very beginning, this is not an easy thing to do. The urban forest is filled with people, it's filled with buildings, Just from the simplest perspective, trees growing in a city with dense populations that are all competing for space in a small area, with highly altered environments that are built up or that are impervious or that are polluted or degraded in some way, or even that are just frequently used. It makes for a challenging setting and a difficult setting that's quite a bit different from where trees have evolved. So to figure out how to go about managing this, you can't just consider the ecology of a forest or the biology of a tree. You need to consider some of these social aspects as well, and some of these physical aspects of the infrastructure in cities. So the urban forest is not just an ecosystem, it's a dynamic, constantly changing social-ecological system, meaning that it's a system that's determined and functions through not just natural processes that we tend to associate with pristine forest conditions, but also from social processes. One of the biggest drivers of, for example, Toronto, 60% of the urban forest is on small residential parcels, people's houses and their properties. One of the biggest drivers of an urban forest for the entire city is just how individual people decide to manage their front lawn or landscape. In my neighborhood, I think half of the tree cover is associated with trees that were probably just missed by a lawnmower and they were forgotten about, and all of a sudden there are these massive things that are covering 4 different properties, and they have a lot of benefits to them but a lot of costs. So we need to figure out how to manage that, and as you might understand, as urban forest planners, as municipal workers, or as practitioners out there in the field, this is a challenging setting. And starting at the very beginning of where this challenges are derived from, the fact that it's I wouldn't say a lack of understanding as much as a lot of disagreement about what an urban forest ecosystem actually is. And that was kind of the starting point of my first body of research, looking at the classification of urban forest ecosystems. So just a little anecdote to kind of drive that point home. This is an article from a couple years ago that was going around, made the national papers in Toronto. Some parents wanted to cut down all the oak trees on school property because of allergy concerns. And granted, there are some very real allergy concerns out there, but as you can imagine, especially within urban forestry circles, there was a lot of pushback from this kind of initiative. A couple of laughs, a lot of puns made, I'm sure. But in the end, something actually happened because of this concern. And they no longer plant nut-bearing trees on Toronto District School Board properties. And if you look at the extent of those properties in the city of Toronto, that's a good amount of land. And that's a good amount of a social concern or something that derived from a process that we wouldn't really associate with a forest that's shaping the urban forest in Toronto. So when you're trying to figure out how can you classify an ecosystem in the urban forest, why are these particular species growing here? Why are more trees dying here versus here? How come when I plant trees in this area, they're not surviving? These are the kinds of considerations you need to make in addition to just, like I said, the biology and the ecology of the forest. And I think a lot of what I'm saying now is kind of reflected in a recent trend in urban ecology. So I guess outside of the world of urban forests in particular, and just more broadly like ecological theory, which has now been applied in cities and adapted to them. So the old thinking in urban ecology, this was probably a couple decades ago or more, was that we look at the ecology in the city. We look at an ecosystem that we tend to know based on its natural conditions. We find a proxy for that in the city, and we describe how messed up it is because it's in the city, and that's urban ecology. And that's ecology in the city. I didn't come up with these terms, by the way, but they are nice. Now, the more recent trend is thinking of the ecology of the city. So this isn't just talking about how humans and the built environment are just some external disturbance agent, but they're in fact part of the internal process of the ecosystem. So it's a more of an integrated way to look at an urban ecosystem, and I think it's a better way to look at an urban forest ecosystem if you want to manage them in a way that accounts for all these social processes in addition to those natural ecological processes. So this ecology of the city is kind of the more recent way of thinking about it. But that's all well and good to think about it as a theoretical ecologist, but if you're a practitioner and you're trying to come up with some usable science-based tools to actually manage it in such a way, that can be more challenging. So that's another thing that I wanted to address in this first body of research that I've done, was to develop a tool or a framework of how to define and then actually classify cities as urban forest ecosystems that accounts for not just the biophysical components that we're used to seeing, but also for the built environment and the human population as well. So this was the urban forest ecosystem classification framework. This is the theory-based framework that I developed to sort of guide the thinking, and then I wanted to apply it as well. And as a case study, I applied it in Toronto, and I took a quantitative approach to my research. So I had to come up with a lot of different variables and data sources to be able to measure these 3 different categories of ecosystem components. And one of the words that I threw into an earlier slide there was heterogeneous. So one of the problems that we have with managing the urban forests is we treat it as this one big entity, but it's really heterogeneous, it's patchy, and going from one block to the next block or one neighborhood to the next neighborhood, they can be incredibly different conditions that have incredibly different management needs. So I implemented this classification at the neighborhood scale, which is a nice trade-off between just going out and managing individual trees or just lumping everything together as an entire city. So based on all those components that I had in the previous slide, and based on variables that describe them in Toronto's 140 neighborhoods, I applied a statistical technique called cluster analysis, and it essentially found out that there are about 12 reasonably well-defined potential ecosystems in Toronto's neighborhoods. And these classes are based on the theory that an ecosystem looks very similar within, so it's homogeneous within an ecosystem, and it's heterogeneous between ecosystems. So the statistical tool wanted to maximize similar conditions within ecosystem class 1 here, and maximize the difference between 1 and 4 or 1 and 2. I'm gonna do it for time. So if we look at a few of these 12 ecosystem classes as examples, we can talk about some of the common trends of just the relationship between ecological and social variables in urban forests. But we can also look at how an ecosystem classification like this can maybe inform urban forest management and planning. So this one here, are people familiar with Toronto at all? Anyone from Toronto? Yeah? So this is, you might know this is Rosedale and Forest Hill. This is the downtownish area, not the downtown core, but the residential area just above it. There's a lot of money there, and as it turns out, there's a lot of trees and green space as well. And this is actually a common theory in urban forests all over, especially North America, where a lot of the research that I've used comes from. So we see where there's a lot of money and there's a lot of affluence, there tends to be bigger houses with more space to plant trees, more money to maintain trees, and more of a, it's called the neighborhood effect in some studies, more of a social pressure within your neighborhood and within the sort of affluence and sort of social trends there to maintain and plant your landscape with trees and to have that green space. So you get this effect where you see these pockets of green and of money, and I term this ecosystem class the affluent forested neighborhoods. And so we want to be able to look at these current conditions at this maybe finer spatial scale to make management decisions, but also to prioritize management decisions. So this next one here, which I've called the industrial parkland ecosystem, is more in the outer edge of Toronto, a little bit more suburban. There's actually a lot of industrial parks and industrial land uses, and a lot of newly developed suburban housing, which has a lot more green space. And the industrial parks have a lot more green space, but there's not a lot of trees there, and there's not a lot of tree cover. So if we're looking at not just the conditions here, but what we might do as urban forest managers, well, this is a great opportunity for greening and tree planting to improve the amount of ecosystem services for the people that happen to live in this ecosystem. But compare that to the previous one, well, what we might want to do there is focus on maintaining an old tree cover, an old canopy that's maturing that has different management needs, focusing on pruning rather than tree planting, just as a simple example. In natural resource literature, that's often called ecological triage. Within management regimes, especially in urban forests, which is my experience in just talking with people who are working with them, there's always limited resources. There's not enough money, time, or people. So you're going to have to prioritize in some way. So if you can prioritize based on the actual conditions across a city and not just based on however else we make decisions in a municipal government, that might be a more sustainable approach, or at least a more ecosystem-based approach. But if you take that more of a ecology of the city approach, and you incorporate the social component and not just the ecological component, you can prioritize and make those decisions based on social conditions as well. So one of the big things that's talked about in urban forestry research is environmental justice and social equity. Excuse me, where in addition to having a lot of more affluent people with a lot more trees, you have the inverse as well, where a lot of less affluent people who live in higher density parts of cities have less access to green space. They get less benefits from trees and urban forests, and that's no good as far as a municipal government's concerned who serves the public. So if we look at this third example of an ecosystem in Toronto, the downtown core, which if you're familiar with the city also includes St. Jamestown, which I think is the highest density neighborhood in Canada, maybe in a race with Vancouver's West End. But there's a lot of people and not that much space for green. So the focus here might be not just on tree planting or on maintaining a canopy, but on creating and maximizing the public green spaces that are out there. Because these people need to have as much access as they can or as they want to this green space in an area where that's going to be challenging to do. And then also in this particular ecosystem, we have a lot of renters as opposed to homeowners. So they might be more dependent on public green space versus trees and green spaces on their own properties. So just to wrap up the whole intent of this research here was to really think about how can we plan and manage an urban forest based on entire ecosystems and not just based on trees, because you need to think about the ecosystem to manage whatever resource or amenity that you're managing. And how can we do so in such a way that's not only current with ecological theory, which is always a good thing, but that also addresses the needs of people living in the cities as well, and not just the needs of the trees. And just to take a step back for a second and let that sink in, I know I probably threw a lot of info at you pretty quick there, but the next chunk of research is kind of layering on to this. So the way I framed it in my in the flow of my PhD research so that I could survive my defense was that first bit of research that I just showed you was, okay, now we figured out what we're going to call an urban forest ecosystem in this sort of whole meta study. Now, what's the big deal with managing it like this? Well, when you consider all these social components and this high density and varying densities of buildings and infrastructure and impervious surfaces, you might rightly anticipate, well, then all of those, or at least a lot of those, could be bad for trees. And that's what I wanted to address as the next major research question was, well, because of this complicated and changing resource, how vulnerable is it? It seems like there's a very good chance, because this is a different environment in which trees have evolved, and there's a lot of competition for space in a city, that this might be a vulnerable ecosystem and a vulnerable resource. So in the more substantive component of my research, but the less substantive component of this presentation, I wanted to figure out, one, how can we adapt vulnerability science, which was developed to face climate change, but how can we adapt it to just look at the urban forest ecosystem, or social ecological system, I should say, and how can we build a conceptual model so that we can both assess it in Toronto, in my case, and then analyze it. So one, where are ecosystems in Toronto more vulnerable? And two, why are they more vulnerable? So the first component was developing the framework and then applying it. I applied it in one particular neighborhood in the field, and I applied it across the whole city using GIS and ecological models. But just to take a step back, what I was defining as vulnerability, in this case not to climate change as the external driver or the exposure causing potential harm or loss of function, but just the city itself. So the vulnerability in my case was the likelihood of decline in ecosystem service supply and its associated benefits that benefit people, that benefit the biodiversity of the urban forest, and that benefit infrastructure as well, like I mentioned at the beginning. And in order to address this, I wanted to build this conceptual framework before I was able to apply the framework. So vulnerability and vulnerability science, which has long history, I didn't make up these components of vulnerability, consists of certain parts that describe how a system functions and how it might suffer a loss of function or an undesirable change. The first of which seems the most apparent when you think of vulnerability, is exposure. So the exposure are the external drivers that may cause harm or adverse effects on the system that you're considering or that you're worried about. In our case, the urban forest. But then, in addition to just exposure or threats, there's also the sensitivity to those threats. So the trees themselves or the forests themselves might have varying levels of how they react to, let's say, stress from a storm event or from a newly introduced beetle that's killing trees. So those are the two interacting components that will really dictate what a vulnerable outcome looks like, which is the loss of ecosystem services or a potential impact. But we also have that human component and an environmental component as well that can reduce our vulnerability, or at least reduce our sensitivity, which is called adaptive capacity. Sometimes it's called resilience as well, but resilience has kind of diverged into its own area of study. But adaptive capacity is, what is the system's own capacity to reduce its vulnerability or to increase its ability to function well under stress? And just to give some examples, I was joking with Lauren that whenever I'm walking around these days, I'm always taking pictures because I think they'll be good in PowerPoint presentations. So here's a few of them that I've done for that. This is in Bloor Street in downtown Toronto. We're talking about exposure. This is one of the major exposures, not the major, but a major exposure in downtown cores, which is just locking bikes to trees, vandalism to trees, just overexposure to high pedestrian traffic. And that can kill trees. That's a direct stress there. But there's also that sensitivity component. And I think this one can often be the less intuitive one and the one that I think is a little bit more interesting. Just because it's got a bit of a sort of a head-scratching component to it. So this is in Winnipeg. And it is a textbook, beautiful tree-lined street, nice cathedral going. These are all mature elms. But if you're walking around the street, you might notice that all these elms have big bands around them. That's because they're being attacked by the Dutch elm disease at all times, and these bands around that prevent them, and they have to reapply them every year. They stop little critters from crawling up the tree and infecting the trees. So there's a lot of work that goes to keeping this alive. And if that work were to stop all of a sudden, we would have Dutch elm disease. We would have an exposure to this particular street, which while it looks quite nice and has a high level of ecosystem services, they're all elms. There's no mix of species there, and they're all really old. So if the exposure were all of a sudden not be protected against, they would all die at once because they're all the same species. They have high sensitivity to that particular exposure. And they're also, like I said, they're all the same age. They're all pretty old. So trees don't live forever. When they senesce and they succumb to age-related mortality, it's probably all going to happen around the same time. So there's not a lot of structural diversity, and that's a sensitivity as well. And like I said, adaptive capacity is, well, how might we reduce that sensitivity or reduce that exposure is to go out and have management or whatever other kind of intervention, or even an environment where you can reduce the stress or reduce the sensitivity. So this is, like I mentioned, one of the modeling and GIS approaches I took. After defining what vulnerability is, I really wanted to see what it would look like across the city. So in addition to just characterizing ecosystems based on the human population, the biophysical landscape, and the built environment, I also classified their vulnerability. So vulnerability is a little bit of a weird concept in that everyone really understands it intuitively, but it's really hard to just go out and measure it. You know, it's an abstract concept. So you've got to operationalize it in some way. And there's lots of ways to do that. The way that I did it was with quantitative indicators and assessment. This is a quantitative spatial assessment of vulnerability. And as you see, remember that downtown core? Well, pretty much all across the board, it's pretty vulnerable. And there's other areas that are varying between their exposure, their sensitivity. This is a Rouge Park, which is a national park, and it's looking pretty good when it comes to vulnerability, as you might expect. So this is how we can go ahead after you've defined it. How can we measure it and help that inform our management regimes in urban forestry? But vulnerability is also not just a spatial thing, it's a temporal thing. If you remember, I mentioned those potential impacts. That's really a function of time. So you can be incredibly vulnerable, or you can be not vulnerable at all as an urban forest, but you won't have any potential impacts if you just take a one-time snapshot. You've got to monitor it or model it over time to really understand what the potential for loss is. And so, in addition to a spatial analysis, I also did a modeling temporal analysis using a model developed by the US Forest Service called iTree. And what we did here was just model different scenarios of stress and vulnerability, and also model different scenarios of management. So on one end, let's do nothing at all. On the other end, let's implement Toronto's brand new shiny strategic urban forest management plan and all their goals that they want to do to make it more sustainable. And let's compare what the outcome looks like after 50 years, 100 years, or so forth, based on variables or conditions in the forest that we like. So I think this really ties in nicely with what Lauren said about predicting, which is a really, I was taught by Peter, and Peter and Lauren go back a while, so that was drilled into me from an early age of modeling, is that you don't want to predict the future. You want to conduct an experiment that deals with time. So by comparing the results of this one particular management option or this one potential disturbance that might come, you can start to get insight into how the system functions to help inform your management. And that was the idea here. And I think the most important thing to take away is that for something like the urban forest and for something like vulnerability, you can never measure it in its entirety. So you need good tools and science-based tools that can abstract the system so that you can experiment with it, like a model or such research like ecosystem classification. And the takeaway from this, as I mentioned just from the beginning, is that the urban forest is a complex social ecological system. So you need suitably, maybe not complex tools, but tools to handle the complexity in order to research it and to management. It's also vulnerable, so you need to consider the different drivers of vulnerability and the different potential outcomes based on management intervention. And like I said, urban forest planners and managers and practitioners, and arguably people just living in cities, need tools in order to help them understand and to manage their trees and their urban forest. So thanks very much. Sorry, Camilla, I might have gone over a bit there. And there's more information on the ecosystem classification there if you would like it. Thank you.